Welcome back to Algebra Half. Lesson 50 is about something called scientific notation, and it's called a scientific way to note numbers because it's often used in the discipline of science, where we're dealing with either really small numbers, 0.0000652 or whatever, because we're dealing with microscopes and really small, can't be seen with the regular eye types of things, or we're dealing with really big things like the distance from the Earth to the Sun. To show that many miles in actual numbers would be really long and laborious. So to make it easier on the eye, we're able to show numbers that are really big or really small simpler using powers of 10. Now this is a lesson that can get confusing for many because we're talking about arrows to the left and arrows to the right, and in a sense positive means arrows to the right, but in a sense positive exponent also will mean arrow to the left. So I think it's important to understand what we're doing here and whether we're getting bigger or getting smaller, and thinking logically about this. If you try to just use cheats, you might get confused. But we will write notes down and see if that can help us. But try to keep this all straight and follow along on page 163. If we multiplied this number by 10, we would count how many zeros is 10, 1, and we would move the decimal. Would it go to the left or to the right? It would go to the right in our final answer because that number, 476, now 4,762.3, see, we moved the decimal over from between the 6 and 2 to between the 2 and 3. We moved it that way. It's now bigger. If we had moved it over here, that number would have been smaller, 47.6, obviously smaller. So when we multiply by a power of 10 that's positive, we're really moving the decimal to the right to make it bigger. A decimal moves to the right when your number gets bigger, and therefore a exponent to the negative will make your decimal move to the left to make it smaller, right? If I move this decimal any more to the left and I add more zeros, it's getting smaller. If I move it to the left, it's going to get smaller than it had been before. Now, if I wanted to write this number in scientific notation, we're going to just make it simpler. It might not seem simpler with a number this small, but when we start getting bigger numbers, it really is simpler. Let's write this in scientific notation, and the first step, right, number 1 on page 163 says place the decimal just to the right of the first non-zero digit. Meaning what we've really done is made this number a number between 1 and 10. It's 4, and then part of a number is back here, a decimal. It's between 1 and 10. Now, how many times did I have to move the decimal over? 2 spots to the left. Did I just make this number smaller or bigger? It's definitely smaller now by moving it from where it was. Therefore, if we want to show what the number is really worth, to make this equal, we need to put this 10 to a power of 2. Because if I, check this on your calculator right now, multiply 4.7623 times 10 caret second, or 10 times 10, it'll go back to the original number. That's what we want to do. So scientific notation is not changing a number, it's showing it, it's noting it another way. We don't want to change what it's worth. We're just showing it in a new way. And this is how a scientist would show 476.23. They would write it 4.7623 times 10 to the second. And they show you that on the bottom of 163. That's example 50.2. The 10 to the second tells us that the number is really with a decimal 2 to the right. Okay? So that's why, in a way, we're also thinking about positive means to the left, because when I know I had a positive number and I'm going to use a positive exponent for my scientific notation, that means I had moved the decimal to the left and that the number is really to the right. So however you want to remember that, we'll use a positive exponent in scientific notation when we moved the decimal to the left, and then when we multiply it needs to be moved back to the right. Which means this one really is when we moved it in scientific notation this way. So if we want to write this in scientific notation, 7,024,000. Now you see why it would be nice if it was just simpler looking. So let's make it a number between 1 and 10. Put the decimal to the right of the first non-zero digit, 7. Show the rest of the number as it should be. Do we need to show these 3 zeros? No, because as is, that does not change the value. Those are just placeholders now. Times 10 is always the way we show it. It has to be multiplied to a power of 10. Now, count the number of times we moved the decimal and which direction we moved it. It had been over here. We moved it 1, 2, 3, 4, 5, 6 spots. What do I do with that? 6 goes up here. Now deciding is this positive or negative depends on which way we moved. And if I moved it to the left, that means this is positive. If I had to move it to the right to make it a number between 1 and 10, then it would have been negative. So by showing it to a power that's positive, it's telling us that this number, the decimal point, really belongs 6 places to the right of where it's written. Now let's deal with numbers that are really small. If we show this in scientific notation, we start by showing it as a number between 1 and 10. How many times did I move the decimal point? 1, 2. Did I move it to the right or left? To the right, which means we're going to use 10 to the second, this time to the negative second, meaning that the decimal point really belongs 2 spots to the left of where it's being shown in scientific notation. How can we check that we've done it the right way here? By putting it in your calculator. Type 6 decimal 5 2 times 10 to the caret negative second, and it'll come out the way it was originally. Let's try one more. 50.4, letter A. It says, I already have scientific notation. 4 and 6/10 to the negative 4. Show it in standard notation. All right, so we can't follow the 1, 2, 3 exactly here. Now we kind of go reverse order. Now I start by checking, is it positive or negative? It's a negative exponent, which tells us that the number had been moved to the right. So this number should really be towards the left. This number, since it's a negative exponent, is really small, actually. If we multiplied by a positive exponent, it would get really big. But this number is going to get really small. So negative exponent tells me to put it back, I'm going to go to the left. How many spots? 1, 2, 3, 4 spots. This is where the decimal goes. So my placeholders require 3 zeros. Now this is gone. So the final answer, 0.00046. If that was confusing with the arrows, that's where I think it's just easier to think of this logically. If a number is being shown to a positive exponent for 10, that tells you that this number comes out big. It gets bigger. If it's times a 10 to a negative power, that means if I multiply this, it's going to get smaller. Okay? So numbers times 10 to a negative exponent are really actually small. And numbers times 10 to a positive exponent come out to be really big. So we're going to use positives when we're talking about things like distance of Earth to the sun, because that's a really big number. We're not going to need a negative exponent for that. But we're going to talk negative exponent when we deal with really small numbers, where it's like a microscope showing, ooh, that looks like Hangman, but a microscope showing us like a little slide, right? And we're measuring sizes of bacteria. That's negative exponents. This was positive exponents. Why don't you pick 2 from A to D, and letter F. So 3 total. 2 from there and this one. Good luck.